Hey everybody, this is our video solution to problem 4 from quiz 11 here in spring 2023, Math 302 at Cal State Fullerton. So, in this problem, we are going to show that a relation is not an equivalence relation. So this is a relation R on Z, so that means it's a subset of the Cartesian product of Z with itself. And the way we define it is x comma y is in the relation if and only if y is a multiple of x. And this multiple, right, has to be an integer multiple. So we want to show this is not an equivalence relation. So why don't we quickly just remind ourselves, to be an equivalence relation, right, we have three things we would have to check: reflexivity, symmetry, and transitivity. All right, so reflexivity would say that if x is in Z, then x comma x is in R. Symmetry would say that if x, y are in Z such that, so this is still before the then, such that x, y is in R, then yx is in R. And finally, transitivity would tell us that if x, y, and z were integers, such that both x comma y and y comma z are in R, then x comma z is in R. So those would be the three things we would have to check. All right, well, we know the answer to one of these is going to be no, or at least one of them will be no. So why don't we just start checking them, right? So how about we'll do reflexivity first. Right, well, if x is in Z, then, well, we want to conclude that xx is in R. Well, what would that mean? That would mean that x was equal to something times x. Oh, that's actually true. X is equal to 1 times x, where 1 is an integer. And so this implies that x comma x is in R. Okay, well, that didn't break it being an equivalence relation. Okay, let's try symmetry. Okay, so fine. So now we get to assume that we have two integers, x and y, such that x comma y is in R. All right, what does that mean? Well, if x, y is in R, that means then there exists some integer m such that y is equal to m times x. Now, our goal would be to show that y comma x is in R, which would mean we'd have to be able to write x as some integer times y. Well, we have y equals mx, right? So that would tell us that you just divide by m, and so 1 over m y is equal to x. And does that imply, this is what clever Carl thinks, this implies, oops, let's get this into a red here. Clever Carl believes that this means that y comma x is in R. Okay, double question mark, right? It's like chess notation. Yeah, why is this a problem? Well, we made it very clear here, right, that 1 was an integer. So we would have to say, oh, 1 over m is an integer. Uh-oh. We can imagine a situation where 1 over m is not an integer. Now, a very typical thing a student wants to do here, is say, oh, yeah, so 1 over m isn't an integer. But it could be. What if m is equal to 1? What if m is equal to negative 1? So in order for us to really show this is not an equivalence relation, we need to find a specific counterexample. So we would like to make sure 1 over m is not an integer. Well, how about we make m equal to 2? All right, so that means we would have to choose some y that was twice some other x. Okay, that's easy enough. So for x equal to, how about we'll say 7, y equal to 14. Okay, that's going to be 2 times 7. We have 14 equals 2 times 7, which implies that 7 comma 14 is in the relation. However, 14 comma 7 is not in the relation, since 14 equals m, or I'm sorry, the other way around, 7 equals m times 14 has no solutions in the integers. So there we go. So this implies R is not symmetric, and that implies that R is not an equivalence relation. All right, there we go. All right, we'll see you next time. Our final video solution for quiz 11. More about equivalence relations, transversals, quotient sets. Oh yeah, it's going to be a blast. We'll see you there.